Welcome to grade 9 math, and we are in unit 6 of geometry, and we're starting lesson 1, angles and angle theorems. By the end of this class, you'll be able to classify angles, use basic angle theorems to solve for missing angles, and review angle relationships in triangles. Before we get started, we just want to review some terms and match their definitions and the pictures. So you could pause the video and try to do these on your own from what you remember from previous years, and then we'll take it up together. All right, so what would be a line? Well, a line is something that goes, a line is a array that goes in both directions infinitely into space with no end. A line segment indicates that a word segment means it must end at some point. So these 2 points are ending at some point. Okay, so that's why they have ends. Array starts somewhere but continues into infinitely into space forever. Okay, so think of array of sun from the sun. So it starts at the sun, a defined point, and extends. Angle. Well, an angle is made between 2 rays. And finally, where the 2 rays meet is called a vertex, this point here. So all these are important terms for our questions going forward. When we want to do the definitions now, we see a straight. So the straight path connecting 2 points and extending beyond the points in both directions. So here we go, extending in both directions. Which one shows an arrow extending in both directions? Our line, okay? Here, a corner point where the 2 rays making up the angle meet. Well, this is where they meet, is the vertex. A part of the line starting at a particular point and ending at another point. So it has 2 endings, a starting point and an ending point. That's our line segment. 2 rays sharing a common endpoint measured in degrees. Okay, so in degrees, we're looking at an angle right here, this one. And finally, part of a line starting at a particular point and extending infinitely in one direction is our ray. Start at one point and extend infinitely. Okay, so those are good terms to know. Next, we want to know our angle terms. So here's our official start to the lesson. Our acute angle is an angle between 0 and 90. Okay, so those could be like this, examples. Okay, they could be a little less wide. They could be much more narrow, right? Okay, a right angle. Well, the right angles are pretty straightforward. Oh, you probably have a little indicator in there. Maybe we'll do that in a different color. Okay, so next you have right angles. Well, right angles are straight up and down, straight over, and usually we're given this indicator. Okay, that's 90 degrees. All right, obtuse angles is being more than 90 degrees. So these are less than 90 degrees. These are more than 90 degrees. So something like this. And so our 90, this would be greater than 90 degrees. These would be over here, these would be less than 90 degrees. Okay, what's the straight angle? Well, a straight angle is a straight line across. It could be 2 lines going infinitely away from each other. And then we have this whole degree would be this whole angle. There's no real angle there, but it's a straight line, so it's 180. We can have a reflex angle also, which is something like, we have our vertex, we have 2 lines, and really this could be an acute, but the opposite of acute angle would be the reflex angle. So it is greater than 180. Okay, so we're asked to do a few examples below and just name them. So why don't you pause the video and try to name these 5, and then we'll take it up together. All right, so we said anything that was going to be greater than 180 on the inside, sorry. Okay, looks a lot like this one, would be obtuse. Here we're told it's 90 degrees, so anything that's 90 degrees up here is a right angle. All right, next. Here we have, well, it would be an acute angle inside here, but they're actually measuring the outside, so that is our reflex angle. And our last two, here is the acute angle. A lot of times we're going to be, probably majority of the time, we're going to be dealing with acute angles and right angles. Anyway, this one's always good to know that sometimes with a straight line, it is a straight angle. All right, so let's move forward into some theorems. Now, a theorem is someone takes a theory that they have and proves it over and over again until it's a solid theory called a theorem. And you can keep doing that, and you can make a theorem can become a law of nature, but we've just focused on these theories, and we basically go from what is normal, conventional rules to math. Okay, so angles are named using points on each of the two lines forming an angle with the vertex of the angle in the middle. So in other words, if this is a vertex for these two angles, there's an angle here and an angle here. We have an obtuse angle, we have an acute angle. Both points share B as their vertex. So if B is the vertex, it's saying it's got to be in the middle of the name of the angle. So the way we name an angle is angle ABC, angle DBC. And so what happens is when we name ABC, we're naming it from A to B to C. Okay? When we're naming this one, it's D. Oh, DBC. And whatever, from going in those directions, that's the angle we created. Okay, so the word, when we form, so this first one, the first angle we have is called a supplementary angle. Formed when a straight angle and a line segment intersects. So here's a line segment intersecting this straight angle. We call this the supplemental angles. The supplemental angles add up to 180. So if I had this one, oh, just a second here. If I had ABD, ABD, and then adds with DBC, these two, okay, add up to 180. Easy to remember because this is all formed on this basis of a straight line, 180. Okay, so if we know one of them, we can subtract the other to find, subtract from 180 to get the other one. Now, a supplemental angle, we always come up with these short forms. So we're going to call this the SAT theorem, supplemental angle theorem, supplemental angle theorem. Okay, now we have something called complementary angles. They're formed when a right angle, of and a line segment intersect. So here we have a right angle, right angle corner here, and there's a line segment splitting those up. So when that happens, the complementary angles add up to 90. So if we have GEF, okay, GHF, G, H, F, okay, and a different color perhaps, F, H, E, F, here's F, H, E, that angle, those add up to 90, the two of them together. Okay, now this is called the complementary angle theorem, the CAT, C-A-T. All right, so we have SAT and CAT, complementary. They complement each other to make 90. They complement each other. These add up together to make 180. So supplement, complement. This one is probably people's favorite, and they like it the most. It's the easiest to remember, is the opposite angles. These are formed when on either side of two intersecting lines, opposite angles are equal. So in this example, angle KMI, angle KMI, so angle KMI, we can say is equal to angle JML. J, and look at the angle symbol. I want you to be able to do the angle symbol, JML. So these are indicated by color. Sometimes we can do them by the bands. Like that would also mean that I don't like. I need that to be a bit more separate. So sometimes use a single band and a double band to indicate. So let's add another one here. Angle KMJ. So look, KMJ is equal to angle IML. IML. Like that. Now this is called opposite angles. So it's called the OAT theorem. Opposite angle theorem. So knowing these three theorems, we can solve problems with angles. Okay, here we go. Find the missing angles, angle measures. State the angle theorem you are using. So how can we find out what M would be? So M is what we're looking for. It's the only missing angle. So they called it M degrees. All right. So what can we do here? Well, we have a straight line and a line segment intersecting. So that looks a lot like when we had the whole thing should add up to 180. So which one was that? So going back, which one looks like that? Okay, we look at them and it looks like this situation, the SAT. So we're going to use SAT theorem, supplementary angle theorem, and we're going to say M will be 180 minus this 50. So M will be 130 degrees. Okay, next B. Well, we have two lines intersecting. So we know when we have two intersecting lines, their opposites are equal. So we have an unknown y and an unknown x. All right, well, we might have to do more than one step here. So which one can we find out first? Well, there's two ways of doing this. We could go, if we look at it as this line being straight line, we can see that this should all add up to 180. Okay, so y, in this case, y is, so we can use the SAT rule, supplemental angle theorem. Again, pause the video anytime and try it yourself before I reveal the answers. So if we use SAT, we're going to say 180 minus 80. Okay, well, 180 minus 80, that's easy. So y is going to be 100. So that was with SAT. Okay, so it's good. Look, we're giving the reason for it. So we're giving it some justification. All right, well, what about x? X is equal to what? Well, if we look at our theorems again, we see we could probably make them opposite angles. They're opposite angles. So there's no math here. It's just x is equal to 180 because that's what those angles are based on the OAT. Very good. So we see how we use the theorems to give us the reasons for our answers. Well, we haven't seen a complementary angle, but here we go. So 90 degrees. Okay, we want to see again what it should add up is to 90 degrees. And we can do the math. So we're going to use CAT. All right. And I want you to pause the video and you figure out what y is equal to. So y is equal to 90 degrees. That's what the whole thing should be. Minus 20 degrees. 90 minus 20 is 70 degrees. So y is equal to 70. Okay, and that's how these problems can be worked out. Well, it's not always just about the angles that are made from line segments. We also have angles within triangles, and some common ones that you may remember from previous years are different types of triangles. So the three angles in a triangle should add up to 180. Okay, so all of these angles should add up to 180. All right, we have different types of angles or triangles. The first one we are talking about is an isosceles triangle when they have two equal angles. So we can see by the indicators, this line and a single line here and a single line here, because they're the same, those two angles are the same. The other thing common is they also have two equal sides. Equal sides opposite the equal angles. Okay, and we see these two equal sides right here and here. And notice that they're across from the angles that are also equal. So that means we don't know this angle necessarily, but it's easy to figure out. We'll try that later. We don't know the side length of this one, and that's not what we're going to do today, but um, that would be a different size. Okay. The next type of angle is an equilateral triangle. And just that word equilateral means and lateral means the side. So equal-sided triangles. So the three sides are the same. Okay. And that forces the only way that you can do that is that if all three angles are equal. And in this case, the only way that three numbers can add up to 180 and they're all equal numbers is 60 plus 60 plus 60 equals 180. Okay. So then we have different types of triangles as well. And so some of the words you may have learned, there's also a scaling. Now scaling, I don't know why it's not on here. A scaling, no angles the same. No angles equal and no sides equal. Ah, no sides equal. So for example, I don't want to take up, but anything like this, that the sides are different, could be scaling. Okay, so looking over here, now all angles in a triangle should add up to 180. So here we go. What type? So find the missing angle measurements, justify your answer. Now, this one looks like a scalene because none of the angles are the same. Can we figure this out? So all we need to do is figure out angle W. They should all add up to 180. Let's pause it here. I want to see if, well, you want to see if you can do this. Okay, so I got you started on this. 180 degrees, and what should we do to get the total? All right, so let's take this up and try. We can try each one. So in this case, we want to do a subtraction. We want to take away these two numbers to figure out this one. So we know it all adds up to 180. Subtract the combination of these two. So I would make a bracket, and a bracket would make sure that we do this first. Okay, so what, oh, sorry, these two adding up together, then subtracted by 180. Well, that would be 180 minus, sorry, we should do that together in our head, or use our calculator, 117. Okay, what's 180 minus 117? Try that out. 63 degrees. Okay, great. Now, the next one's kind of a giveaway because we know that this is a equilateral triangle, and the only way the angles work out is if they're 60, 60, and 60. They all add up to that. So x equals 60 degrees because of the equilateral triangle rule. Next. Okay, so we have a bit of a different look here. We have two equal sides to make this isosceles. Okay, that means that this angle and this angle are equal. So in other words, we actually know that this is 70. So by knowing these two, we can combine them to find out that third angle. So we would know that angle y equals, actually, why don't you pause it and try this one on your own. I want you to try it and make sure you understand it. And then we can take it up together. Okay, so again, we have 180 minus the combination of 70 and 70. Well, that's 140. So 180 minus 140. We should have our degree symbols on there, shouldn't we? Okay, and 180 minus 140 is 40. So that's it. Always check that your numbers look the same. Like you all know what a 90 degrees look like. So when we find out that W is 63, is that narrower than 90 degrees? Yeah. So that's a decent number. Like we know that's in the right ballpark. We know that is makes sense. We knew that 60. There's only one choice here, and we look at it and go 40 degrees is pretty narrow. It's like half of 90. So yeah, that looks pretty accurate. That looks pretty um, reasonable. So that is the examples of the day, and then you have practice questions. So again, um, classifying them as acute, obtuse, or reflex. Maybe straight also. I don't think there's a straight one there. What else? Determining angles from what we've learned. Okay. This one's just missing an underline there. There should be a line there, so then you're going like that. All right. And doing like we had in the examples. And then determine other measurements. Okay. Making you think a little bit beyond. Some combinations might make it tricky. Okay. So we're left with angles are classified by their size, their acute, obtuse, or reflex. Various angle theorems can be used to solve unknown angles. We can use the supplemental angle theorem, the complementary angle theorem, and the opposite angle theorem. Also, triangles have some special properties. The sum of all the angles in a triangle should be 180. We have isosceles triangles that have two equal sides with two equal angles. We have equilateral triangles that have three equal sides, meaning also having three equal angles. All right, so that's it for this lesson. Remember to do your practice questions, and we'll see you next time.